Okay, so we're going to continue with page 4 of notes, which is just a little bit of practice to kind of help you with your with your classwork that we're going to be doing during class as well while I'm giving a state test. So the first thing that we're going to do, remember, these are the different types of parent functions that you may see. We did talk in pretty good detail about these 3. So remember, the absolute value of x makes a v, lines form a straight line, and x squared quadratics, they form little u's basically. So what we're going to do is focus on parent functions, and what this problem is doing is it's giving you a parent function, and it's asking you, sorry, my camera is like a little crooked, there it goes, and it's asking you to describe the transformations. So when you're doing these problems, you'll have to kind of look on page 3 to describe the transformations that's happening. Also, you could graph this. So the parent function is the square root of x. So if you look at the top of page 4, the square root function kind of looks like this. Like it's kind of weird, it's like curved a little bit. So when describing what happens, it's important to ask yourself, is the parent function intact? Well, looking at number 1, all that's happening is we are adding 7. So our parent function is in fact intact, like nothing is in it. Notice the difference between 1 and 3. We can clearly see the square root of x, whereas this problem we can't. Something's been in there. So I'm going to look back at the notes that we took yesterday. So right here, where I'm adding k, or a constant, that's a vertical translation up k units. Well, in this case, this is a positive 7, which means I'm going up 7 units. So let me find my blue pen real quick. Okay, so from here, what that means is this positive 7 means I'm going up 7. So you can put an arrow, or you can write the word up 7. Like that is literally all it means. I'm shifting up 7. That's it. Next, I can clearly see the square root of x. Again, the function has not been messed with. I just have a number outside being multiplied. So again, looking at this cheat sheet from page 3, let me actually pull up. Sorry, I gotta move some stuff around. Probably not prepared. All right, here we go. So the number is being multiplied. It's smaller than 1, so it kind of looks like this problem. Notice how we have the function intact, and it's 3 over 4. So looking at our answer, I'm going to scroll over. This is called a vertical compression because the number is less than 1 but bigger than 0. So I'm going to go ahead and write vertical compression. Because that's what's happening to the function. And you can also abbreviate this as VC. So a vertical compression means the function is like squishing towards each other. Like it's going squish. All right, now the next one is inside of the function. Notice how I don't clearly see the square root of x, which means this is a horizontal shift. Looking at the value inside, this is a left to right shift. Remember, however, when it's negative, this is actually shifting to the right. So I'm going to move this over. Again, I'm looking on what we did yesterday. It's the function, but minus inside. So it looks like this x minus h. That's a horizontal translation to the right h units. So this is just right 8. Or you can write, oh, no, not 8, I'm sorry. That should be right 3, not 8. Sorry about that. So we're going right 3. Okay? Remember, if it is inside of the function and you can't clearly see the square root of x, that is a horizontal. Something is happening horizontally. All right, number 4. Again, I can't clearly see the square root of x, but I'm multiplying a number inside of the function. So I'm going to look here. Multiplying inside of the function is here. Well, 4 is greater than 1, so this is a horizontal compression. It's all about using the chart. And you can abbreviate this as HC. So a horizontal compression, that pushes it towards itself, like the function is going to squish this direction. I don't know what kind of arrow that is. Okay. Now number 5, I can clearly see the square root function. Oh, that's not a headline. I can clearly see the square root function, which lets me know that, okay, this is a shift vertically. It's kind of like number 1. This is up 7. Well, this one is down 48. So I'm shifting down 48. So you can draw an arrow or you can write the word down. Number 6 is kind of the opposite of number 3. So in number 3, this is negative 3, which means to the right. This one is positive 7, which means to the left. So we are shifting to the left 7. Remember, look for the function as a whole, and that's going to make it a little bit easier. All right, again, on number 7, I can clearly see the square root of x, which means if I can clearly see the square root of x, then it's something happening vertically. Looking at my list from yesterday, negative outside of the function is a vertical reflection over x. So vertical reflection, you can use VR as an abbreviation if you want to. So this is a vertical reflection over x-axis. If you want to abbreviate vertical reflection as VR, you totally can. Okay. Next, 6 times square root of x. Again, I see the square root of x clearly being marked. So notice in number 2, the number that's being multiplied, if it is less than 1 but greater than 0 in terms of absolute value, then this is a vertical compression. If it's bigger, it's going to be a vertical stretch. So it's a vertical stretch. You can abbreviate that as VS. And a vertical stretch pulls the function like this, away, like it's going to get closer to the y-axis. Okay, and for the last one, this is kind of the opposite of number 4. If the number is larger than 1, then it's a horizontal compression. If it's inside of the function and is greater or less than 1, it's a horizontal stretch. So this is called a horizontal stretch. It would help, again, if I could spell. Let's see, there we go. So it's a horizontal stretch. You can abbreviate that as HS. And horizontal stretches pull it horizontally. So the function is kind of moving this direction. Hopefully this makes a little bit more sense than it did yesterday. I'm hoping that just kind of going over page 4 again will have it make more sense, and using the chart is helpful. So down at the bottom, we want to, given the function, state the parent function and the transformations that are occurring. So remember, to find the parent function, I'm going to write the whole function right here, 3x squared plus 2. To find the parent function, you remove any coefficients and any constants, keeping the exponent. So looking here, This 3, that's a coefficient. I'm going to cross it out. Positive 2, that's a constant, so that goes away. And what I'm left with is x squared. So my parent function is x squared. Remember, exponents stay. Next, I'm going to talk about what is happening in the equation. Well, looking at the picture, I can clearly see x squared, which is important because x squared is my parent function. So now, each little piece is going to do something for the problem. So I'm going to start with, let me find a different colored pen here. I'm going to start with the positive 2. Positive 2 is outside of the function. It's kind of like this number right here. I'm just shifting the function up 2. So the positive 2 takes the function and it goes up 2. Or you can draw an arrow. It's completely up to you. Then you have the number 3 that's being multiplied to the parent function. So again, this 3 is also going to do something. That 3 does something. It's not just sitting there. Okay. So number 3, what that does, it's being multiplied. It's greater than 1. So if I'm looking at some examples up here, right here I can clearly see my parent function. This number is greater, so this is just a vertical stretch. So I'm just going to write vertical stretch. And you can always abbreviate, just abbreviate enough to where I can follow. So once you've marked each piece, you're pretty much done. Like, that's all it's doing. It's shifting up 2 and a vertical stretch of 3. Okay. Next, in this problem, I'm going to again write the parent function. So I'm going to write the whole thing. I'm going to get rid of any constants or coefficients. Well, this plus 3 is considered a constant, and this minus 7 is also considered a constant. So what I'm left with is the absolute value of x, which is now my parent function. So when looking at the problem up above, I don't see my parent function clearly. However, I do see this plus 3 sitting outside of the parent function, which means even though I can't clearly see the absolute value of x, if I ignore this minus 7, now I can see it. So this is going to shift up 3 because it's sitting outside of the absolute value. So I'm going to go up 3. So up 3, or you can draw an arrow. On your practice, since it's digital, you're going to want to just type the word up. Then you have minus 7. Now again, this is inside of your absolute value. So if I'm looking for an example, I'm going to go up here and I see a minus 3. Remember, inside is opposite, so it's actually going to the right 7. So this function is going up 3 and then shifting to the right 7. Or you can use the arrow. Okay, let's try the next one. So we have negative 2/7 x to the 4 minus 8. Again, we're going to cross out any coefficients and constants. So negative 8 is gone. Negative 2/7 is also gone. So our parent function in this case is x to the 4th. So looking at my picture, I don't have any horizontal anything because I can clearly see x to the 4th. So I'm not going to have anything horizontal. If you can't clearly see the parent function, then you're going to have a horizontal shift, stretch, or compression. All right, so let's kind of look through our problem here. I like to identify the constants first. It's easier. So I see minus 8. So if it's vertical, which it is because it's outside of the function, this means I'm going down 8 units. So down 8 or arrow 8. Okay. The next thing I see, now I'm going to ignore the negative sign. I am only going to focus right here where it says 2/7. The negative sign is something different. It does something else. So I'm going to look up here. I'm looking for outside of the parent function, less than 1. I see it here. That is called a vertical compression. So the 2/7 represents a vertical compression. Remember, it's all about using that little chart. If you're stuck, you can always graph. It might make it a little bit easier. Last thing is this negative sign. So this negative sign does mean something. So if I'm looking here, I see a negative sign outside of the function. That is a vertical reflection over x. So down at the very bottom, that negative sign, that's going to be a vertical reflection over x. Okay, so vertical. Oh, I misspelled reflection. There. Vertical reflection over x-axis. All right. Struggled just a little bit, but we finished. The thing about function transformations, before you do your practice, is each thing means something. So like each negative sign, that means something. Multiplying means something. Adding, subtracting, it means something. So what I would recommend for you is identifying the parent function by removing all that extra stuff and then focusing on what each individual piece does for the problem.